team, one satellite. That is how we are building Africa's space future. Not by waiting for permission. No, we're not doing that. But by acting with purpose. Welcome to Project D.A.W.N podcast. I am your host, Dr. Femi Ishola. I'm the principal investigator and project manager of Project D.A.W.N. With me today is Dr. Tejumola Taiwo, an assistant professor of aerospace systems engineering at the University of Southampton, United Kingdom. Welcome to the show, Professor Taiwo.
Thank you very much for having me, and it's an honor and pleasure to join your podcast today. Thank you.
Excellent. Please tell us about yourself. Tell us about your journey from Zaria. You started your career, your education at the Ahmadu Bello University Zaria, and now today you found yourself at the United Kingdom as an assistant professor. Tell us about your journey. We want to inspire the African youth out there.
Yeah, so I mean, I think the really starting point of my journey, I would say, is from Oshodi. It's not even from it's not from
Which one? Is it
Zaria.
Oshodi okay or Oshodi Sale?
Both, yeah. So I grew up there. I had my secondary primary education there. So I would say, everything that we see today actually, kind of started from that part of the world. So yeah, I went to Zaria, ABU Zaria. I did electrical engineering. And I mean, it's really that inspiration of, solving problem. So I think I remember when I was really in my, when I was young. So when I have, what is it called now, toys, I usually just destroy and try to reassemble. And
there used to be an electronics market at Oshodi.
Yes.
I used to be a frequent customer there, buying
yes, I went there too.
capacitors and all that.
Capacitors and inductor, everything. So yeah, so all of those, I mean, I would say, actually kind of pushed me to where I am today. And of course, I had my degree at ABU Zaria. And then I am sure I did had early career with the Nigerian Space Agency. And so, yeah, I mean, it shows that no matter where you are, no matter who you are, you can always be who you want to be with hard work and perseverance. Yeah.
Exactly. Beautiful. I think, Dr. Taiwo, me and you, we share a lot in common, actually. Maybe I'm your candy.
Interesting.
We share a lot in common in terms of our career progressions and
absolutely,
the institutions that we both attended. You were also a member of staff, an engineer at the National Space Research and Development Agency in Nigeria, NASDA.
Yes.
Tell us about your contribution when you were there at NASDA.
So at NASDA, I actually was. I worked at one of the research centers at Obafemi Awolowo University. And so actually my career started from NITDA, National Information Technology Development Agency. So that center transitioned to NASDA. And so the staff, we were like, taking over. So that was how I joined NASDA. So my center was in Ife. And so I would say after that, so being in Ife, at a point, I was transferred to Akwa Ibom in Uyo. So there was a new center and, the tradition. It's kind of civil service job, right?
Yes, exactly.
You have to move when it's time to move. So I was transferred to Akwa Ibom, and I was, so I came across this cancer training program. And I would say that's actually changed everything. So I went to Japan for a few weeks for that training. And then, I just fell in love with Japan. Then
you did amazingly well in Japan. And you were the pioneer project manager of the BEST project, which you actually brought an award, in honor of the university, the Airbus Innovation Award. What a very resounding success back then. At Kyutech, you worked on the HORYU-IV satellite mission, okay,
Yes.
developing, the low-cost double-lagma probe for plasma measurement in space. For our listeners that doesn't really understand plasma physics, okay, I want you to please break it down. What does that instrument actually do? Why does it matter for satellites in orbit? And what did you learn from putting the real hardware in a real spacecraft back then in Japan at Kyutech?
Yeah, so space is the environment of space. So if you go above 1,000,
100
100,000,
kilometer.
right?
100 kilometer.
100
Kama line.
kilometer,
Yes.
you go above Kama line, you go, to different orbits, the low Earth orbit, the medium Earth orbit, and geostationary orbit. That space and that environment is actually plasma. So
Yes.
that environment is 99.9% plasma, and it is vacuum. There is no air there. And plasma is just the fourth state of matter where matter exists in form of charge particles. So
Yes.
we have solid, we have liquid, and we have gaseous states. That's the very common one we talk about. So the fourth state of matter is when the gaseous states now become, charged particle in form of electron and protons and also neutral molecules. So that is the environment of space. And if you want to put satellite in space, you need to understand that environment. And how you understand it is being able to measure the state of plasma. So it's just like human. We need to measure our temperature to know, oh, are we sick? Are we okay?
Yes.
So we need to be able to
We did a
measure.
lot of
So
that during COVID-19, right? Measuring our
yes, we
temperature every now and then.
absolutely, absolutely. So the plasma instrument is kind of the temperature for satellite, just being able to characterize the environment in which the satellite is placed. So, and I mean, being able to build hardware that is part of a satellite. Satellite is a very complex system, right? So one of the hardware, if you build an hardware, it needs to be able to, interact and, work as a system with other hardware.
That's
So
right.
this is very fundamental. And I mean, the skill you gain from that it's really very unique. You don't get it anywhere else. Yeah.
Wonderful. I think that mission was a successful one, the HORYU-IV. That was
Yes.
the first hands-on on the real satellite mission. And,
Yes.
that was a springboard for you actually to become the project manager of the BEDS project.
Yes.
Arguably, I think you would agree with me that the BEDS project was the most iconic of your career, because
Yes,
that basically,
absolutely.
springboard you, to a lot of opportunities afterwards. Tell us about your
Mhm.
experience with the BEDS project. And
So the
yes, go on, please.
So the best project is really, it's a international kind of satellite project. It was the first time in the world that different countries will come together to build similar satellites. Of course, it was 1U, which is just a 10 centimeter, 1 kilogram cubic satellite. So it's really students from Nigeria, Ghana, Mongolia, Bangladesh, and Japan coming together. Of course, we were already students of the university at the Kyushu Institute of Technology, Kyutech. So the Kyutech was able to convince the different countries to participate, and those countries paid for the satellite actually. But it's really a unique way for students to learn how to build satellites in a team that is not really people you are used to. And I think this is very unique team work, team spirit, developing that kind of skill and experience. I think is really very unique.
Wonderful. The project was successful. You had all the satellites, which you were the project manager, were launched into space, delivered via the International Space Station to the destination orbit. Congratulations once
Thank
again,
you.
Dr. Taiwo.
Thank you.
Because of that, you won the Airbus Innovation Award. Tell us about that. That moment. You were called to the
Okay,
stage.
so yeah, so being a Nigerian that I am, as a Nigerian, there's a slogan, Nigerian they carry last,
Like
we
you, Kububu,
always we always want to go a step ahead. So
Yes.
I was always looking for opportunity for, just looking out. Then I came across that award, Airbus Diversity Award for Innovation. And I was like, oh, let me talk to my professor. And I spoke with him and he said, oh, if you want to do it, just do it. Go ahead. Then I sat down, I did all the questions, I
Paperwork,
did everything,
applications.
homework. And yeah, I went to Canada and I presented a project and we got the award. That was so amazing. So, I mean,
Actually,
that shows the kind of project we worked on. It was international, very engineering, high level engineering and system integration, and also, promoting diversity.
wonderful, wonderful. I think that award wasn't just an award for Japan. It was also an award for Africa. Okay, because
Yes. Yeah.
now we had for the first time African engineers putting their hands dirty, really building stuff, albeit in a foreign soil. And this is exactly why we have Project D.A.W.N now. Project D.A.W.N is trying to bring that same experience to the African universities. Instead of our people, traveling outside the shores of Africa, selling their houses, selling their properties, trying to get on a plane to go to Japan, to go to USA or elsewhere to learn how to build satellite, we are bringing our experience, to Africa. And this is exactly so model Project D.A.W.N. How do you see that playing out, Dr. Taiwo?
Yeah, I mean, so eventually every country needs to be independent. I mean, if you look at the world politics, so countries are becoming more, disconnected, I would say, in quotes. And so I think it's really very important for every country to be able to build a complex system like satellites
Yes.
by themselves in their country. Because, I mean, already we know there are a lot of barrier to even to order some kind of electronics from abroad, sometimes can be very complex. So not to talk of satellites. So in the past, I mean, most African countries, their satellites are actually developed outside of Africa. But how long do we want to do this? It's more expensive. The knowledge transfer is not
Not
sustainable.
qualitative. Exactly.
It's not sustainable, and also it's not, we don't develop infrastructure, because if you don't build those satellites in your country, if you build in your country, you develop infrastructure, and also it will have some spin off to other industries. So I think it's really the way to go, and I agree that this project, uh, if I mean, when it's as it's spinning out, as it's developing, it will really catapult many African countries to be able to be self-reliant and build system by themselves.
Absolutely. This is the goal, Dr. Taiwo, and we are very proud to have people like you and other faculty members of Project D.A.W.N who are the front runners in the industry. We are not short of talent.
Yes,
There are
yes,
Africans everywhere, okay, doing
yes,
exceptionally well. So what we're trying to do
absolutely.
now is to actually magnet them, bring those knowledge that they have to do actual action, okay, on the
Hmm.
African soil. But
Hmm.
we are not naive, okay. We're not expecting a free run. This is not going to be a hot knife through the butter. And
Hmm.
this is exactly what Framework Systems has been built. We've built our company in such a way that uh, we can handle the storm. Okay, what are some of the storm that you see? Okay, that you foresee or envisage in trying to develop this kind of framework or initiative for Africa?
Yeah, I mean, so I'm in the academics, so I think number one, I would say that many African countries, we need to review our curriculum. So, because I mean, I did my bachelor degree in Nigeria at ABU Zaria. I would say it was a very rigorous study, very,
Yes.
but I
Everything
hope,
theoretical, right?
yes, I hope that,
Yes.
the university have changed, and because the technology of the engineering we do is changing every day, and there are even better tools, more simpler tools. There are simpler tools to pass this education, to train people, and you know, I believe that also Africa needs to be very intentional about this.
Yes. That's a big
So
one.
we need to be very intentional. So it's not just, oh, we want to build satellite, we want to do this. So every African institution need to be intentional. We need to say we want to do this, and this is the milestone. This is how we want to go about it. And
Speaking
also,
about sorry to interrupt you. Speaking
yeah,
about being intentional and the timing that we are right now, we see currently we have a couple of astronauts orbiting the moon, or let's say
okay,
almost orbiting the moon, right?
yeah,
When was the last time we had a mission to the moon? Several years ago.
yeah,
In fact, let me say several decades ago. So many people say, why did it take so long, okay, for America to return to the moon? I think it's all about this intention, okay,
hmm,
this readiness and this drive to go. And I think now they found a reason to go back to the moon under the Artemis Accord. I think Africa needs to, do the same. Like you're rightly saying, we need to come up with that intention. Okay,
yeah,
without the intention, without the political will,
hmm,
space is a capital intensive, endeavor. Uh,
yeah,
it's also a very risky endeavor. Nothing
yeah,
is guaranteed. There can
hmm,
be failure at any point. Without institutional governmental policies, I don't think much can be done. Because of time,
yeah.
Dr. Taiwo, let me quickly ask you. After you left Kyutech, you spent over 5 years at the International Space University as a professor. You were the faculty lead, for the Space Payload Laboratory. Then, ISU is a very unique institution. I'm also a proud alumni of the International
Hmm,
Space University,
hmm.
which brings together students, from different countries through the interdisciplinary space education. What was it like leading the laboratory in that environment, and what did you learn about teaching space engineering to students from vastly different backgrounds and different skill level?
Yeah, I would say getting to ISU, I would say it was a very good opportunity for me to develop. And, coming from QTech, where, I mean, at QTech, in our lab, then we had maybe 40 to 50 students, and almost 60% were international students.
Yes.
So that was kind of, training, kind of prepared me for ISU.
For ISU, that's
So
right.
at ISU, it's also very international. So I told someone before that at ISU, I don't speak French. It's just English. That
English.
it was just my payslip that was in French. So yeah, at ISU, I mean, ISU is a very unique university, having, uh, applying the three I's: international, intercultural, and
Interdisciplinary. Yeah.
interdisciplinary. So I also had the opportunity and chance to work with colleagues from, different aspects of the space industry, space education, policy, human performance in space. And I mean, that was really very unique. I don't think there is anywhere in the world you get such experience.
Yes.
And I would say it's really the kind of training that students need. So building satellites is not just engineering. It requires you to be able to understand the
The
ITU kind
economics
of
aspect, the
the
legal aspect.
economics, the policy, the law, and
Yes.
all of that. So I think ISU really helped me, and I would say the preparation actually, I would say, is really from Kyutech. Yeah.
Impressive. So our goal now is to turn African universities into Kyutech and ISU. And that's exactly what Project D.A.W.N is all about. You are now a lecturer at the University of Southampton, one of United Kingdom's top aerospace engineering departments within the Russell Group. Your research focuses on innovative plasma instrumentation for small satellite. What are some of the open questions in this field that excite you the most? And how does CubeSat and nanosatellite create a new opportunity for plasma science and larger mission? I have to say, there's an advert right there. You are accepting PhD students, in your faculty to join your research group. Of course, our listeners, Project D.A.W.N, listeners, they'll be very happy, to reach out to you. So please, this is your pitch now to them. Tell them why, tell them why they should come, to your departments, to your faculty, your research group. What are you trying to solve, and how does it help your career?
Yes, so like I said, space environment is really very tough. Just like people say that space is hard. So it's really, so my research is how, instead of using, so one thing about data from space is important to be able to have advantage of temporal resolution. So with how much data can you get per time? That is really very important. So using small satellites, they are cheaper. They are shorter schedule to make. So using small satellite means we can have more satellites in space, and this can tremendously increase the temporal resolution. But the problem with that, with small satellite, is that their reliability is really still very low. So this research, the student will be able to develop that instrument, and not just developing the instrument, but also introduce a concept of optimization. Where is the best point to place the instrument? And, this kind of thing actually drive the success or failure of the mission. So, if you are motivated and have a skill already in plasma science and basic electronics, I think you should give it a try. And yeah, it's really very important to be able to understand the plasma environment in a more, kind of having more temporal resolution in terms of time, having more spacecraft in space. And the only kind of instrument that can do that is the small satellite, because of the advantage of their cost and shorter development schedule.
Yes, to break it down for our listeners, who are new to space systems engineering and orbital dynamics, a typical small satellite or any spacecraft in low Earth orbit, altitude of about 100 kilometers, will have an orbital period of about 90 minutes, which means that the satellite will go around the planet every 90 minutes. And at each time it passes through the planet, you only get, let's say, about 10 minutes, let's say maximum 20 minutes. If you're so lucky, maybe the zenith angle or some other orbital characteristics in your favor, probably you get maybe max 30 minutes of line of sight to your ground station. Yeah. So I think what Professor Taiwo is trying to explain here is that the more satellites we have in the same orbit, or maybe even in around the same orbit, the more access you have, to your suite of ground stations, and also you can conduct, several experiments like the plasma instrumentations and all that. It's quite interesting because one of the things that Project D.A.W.N is going to be doing is to think of payloads that's going to be going into our satellites. Okay, so the batch one that we are doing already has the software-defined radio and the IoT payload that we are engineering. I think subsequent batches will have to think of a new payloads that we can involve in our mission. And I think that opens up an area of collaboration with your University of Southampton, and some other universities that are going to be joining, Project D.A.W.N. So this is quite interesting for our listeners, the young engineers out there. feel free to check out Professor Taiwo's, call for applications. Of course, being an African, you should be sure he would place you on a higher priority.
Oh.
Okay, Professor Taiwo, there are Nigerian engineering students right now, okay, sitting in the classrooms at ABU Zaria, at IFE, in Ghana and South Africa, in Unilag, who have the same talent and ambition. We both know this, okay? African students, are actually very exceptional. With the little tools and resources that they have, they are able to abstractively, learn the theory and, make do with what they have. And this is why, we excel a lot when we go out there to Western world, because we have a very good footing, okay, in terms of the theoretical background of what we are studying. Yeah. But there is no clear pathway, okay, from where they are right now, these students, to where, for example, me and you are currently. What would you say to this student? What words of motivation do you have for them?
Yeah, I mean, like you said, there are a lot of smart people in Africa, young, smart people, so many. But yeah, I understand that the opportunity is very limited. But what I will say is, and one thing that is also missing in Africa and maybe most developing countries is mentoring. Yes. So these young people don't have mentors. So I think, yeah, maybe as part of what you do in Project D.A.W.N, so you already have some selected faculty member and all of that. So these people are kind of mentor. So my advice to these young people is to reach out. So now internet is really very cheap to use. So instead of being on other social media and
Instagram, watching
yeah, why don't you use things like LinkedIn, where you can reach these people? Because most of these people can be reached on, as simple on a platform as simple as LinkedIn. So why don't you reach these people? Just go send them something in their inbox. So if you send to 10 people, I'm sure 4 or 5 or 6 will reply you, and you can get the discussion going. So I think mentorship is really very important. And also just keep going. That's what I always tell people. So when you apply to something, to a project, or you apply and you fail, keep going. Try again. And when you will stop, you should stop when you have done it 100 times. So I'm sure before you get to 100 times, because at every time, and when you do that also, when you fail, it's always good to ask for review, for feedback, So I know many young people in Africa don't ask for feedback. So they just
failure is part of success. And if you don't learn how to fail, you cannot excel in space industry.
Yes. And getting the feedback is really also very, very good and very important. Yes. So yeah, I mean, I give feedback to students when they submit something or I interview them. You should get feedback, even if you are not successful. So I mean, this is really very important. Try to get feedback, try to get mentor, and just keep going. It's
talking about failure, Dr. Taiwo, talking about failure. Because sometimes if we don't share our experiences with failure, maybe the student out there wouldn't understand, even the top people, they fail to. Sometimes you get rejection of your journal paper. Sometimes you build a circuit, it doesn't work. Sometimes experiment after spending 7 months amounts to nothing.
Crazy.
Share some of your experience with failure and how you handle the situation.
Yeah, so I mean, when I moved to Japan for my master program, so I worked on plasma instruments, and that is actually I have to generate plasma, and how I generate plasma is there's a vacuum chamber. I have to make vacuum, and I have to use RF to make the plasma, and I have to find the best configuration. So because there is no software, I will go to and ask, or I will simulate. I need to do it. Yes, I need to do it several times. So I mean, I did that for almost 1 year, and it's always very bad data, you know. So 1 year, and I mean, you know Kyutech, right? So every week you have to do research meeting with the
Yeah, research
professor.
seminar.
Yeah, research seminar. You have to
And then you go to the
present your
seminar with
result.
no real data.
No, you are dead. So yeah, all of that. I mean, we
I
failed.
know
I mean,
Professor Cho will just be looking at you and be, and be banging his
yes, 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 yes. So I mean,
yeah,
I have been in that situation, and I mean that's what I tell my students also, that it's okay to have bad data. It's okay if it doesn't work, but show it to me. Let's discuss
yes,
about it. Let's see how it can be improved. So failure is really part of life, and as an engineer, as somebody who wants to be successful, not even only in engineering, even in business, you fail. So just
yes,
pick up yourself and go more and more. And even like you said in research, when we make publication, sometimes it's just outright rejection, and you'll be wondering why. And that same paper you submit to another journal, and it's just
it's accepted.
accepted
Yes.
or just a minor review. So it's really not, it doesn't mean you are a failure. It doesn't mean you are
Yes,
not smart enough. It just means you need to tweak something, you need to change something, and the next one is going to be boom,
even
success.
better. Yes.
Yeah.
Yeah. Well, still on that failure, for the benefit of our listeners, young engineers and students listening, one of the brush I had with failure during my PhD at Kyutech, my research was optical communication systems development for small satellites. So I was building a system, for precise, pointing of fine pointing actually, okay, of optical beams. And
Okay.
one of the microprocessor I had to use, for my control architecture back then, actually has a ball grid array. Okay, a
Mm-hmm.
ball grid array, of course, highly dense,
Mm,
connector system for PCBs.
mm,
I over, it's actually funny. I underestimate, what needed to be done. Okay, to get that ball grid array sold out to the photodiode array that I was experimenting with. And
mm,
because of that, I would always, relax, I would pay attention to other things
mm.
until the day came when I needed to, fix the unit. And while I was trying to fix it, trust me, everything fell apart. And guess what? The following 2 days, I was supposed to give a research seminar to Professor Cho.
That
You
must
know,
be ter yeah.
at that time, I was a dead meat.
Yeah,
I
yeah, I
was a
can
dead
imagine.
meat. You
I
know,
can
and
imagine.
then, but what I did, which was was a good turning point for me. I learned that if you fail, all you need is honesty. Okay,
Mm-hmm, mm-hmm.
when you fail, when you get a rejection letter from a journal, just be objective. Okay, listen to try to understand what they're saying.
Yeah.
Okay, and be honest with whatever you're trying to do. I calmly went to Professor Cho, a day before the survey. I said, sir, yeah, I don't gas.
Everything has fallen apart. Yeah.
you know, the ball grid area has fell apart. And they laugh and they say, okay, all right, don't worry. Don't worry. Yeah, do you still want to have the seminar? I said, yes, I'm happy to talk about the seminar. And then he said, okay, no problem. And then because of that, it gave me an opportunity to order the right parts, okay, for that, for
Yeah.
that system. And here
Yeah.
we are today. I finished my PhD successfully in
Yeah.
due time. So don't
Mm,
be afraid to fail. And,
mm.
you will really learn from that. And it's going to be a good experience afterwards.
Yeah.
Dr. Taiwo, you
Yeah.
are a pride to Nigeria. Okay,
Thank
we are
you.
very proud of you. You have done amazingly well.
Thank you.
We need an army. Okay, we need a legion. Okay, of engineers like you and me. Okay,
Yeah,
who
true.
are top notch, who are
True.
able to develop Africa capability. Okay, nobody's
Mm.
going to do it for us. China,
Yeah.
Russia, USA, no, forget about it. They are only in
Mm.
for business. They
Yes.
come, they take the money, and off they go.
Mm.
Final question before we close.
Mm. Yeah.
If Africa is going to become a serious, self-sustaining participant in a global space economy, not just a customer, which we have always
Mm.
been, we buy satellite, we pay a lot of money. Recently, China threatened Nigeria, they're going to shut down our satellite.
Mm.
What are the 2 or 3 things that absolutely must happen in the next decade?
Yes, I think The very first and the most fundamental one is we need mass development of capacity. We need to train people. So people need to be trained. I mean, we are not going to get a lot of people trained in next year or next 2 years. So we need to have this timeline. How many young people do we want to train in the next 5 years, and how are we achieving it? How many from maybe different universities? And this should be done across Africa, not just in Nigeria,
Yes.
not just in Egypt. People need to be trained. If we don't train people, this trend will continue to, I don't know, till forever. So people need to be trained. And after they are trained, there should be infrastructure they can use to, when you get training, you want to get your hands dirty.
Yes.
And I mean, like this project, it's something that the national government should support because it's a platform for them to train people. Like this is just use it, and getting hands dirty by, infrastructure need to be there. And these infrastructures, they are not like crazily, they are not crazy expensive things because we already have universities. Our university
exactly
have
that has the
Department of
laboratories, they
Mechanical
have some of those
Engineering,
things.
yeah,
Exactly.
and they have lathe machine, they have oscilloscope, they have power supplies. So we just need to see how these different departments will come together, and the infrastructure they already have, how we can improve it, how we can add more. So training, infrastructure development, and the third one I would say is funding.
The big elephant in the room.
Yes, because everything we have talked about in the last maybe 40 minutes, without money, it's nothing. So the money, the cash, the funding that African government used to buy satellites, I think they can just forgo that and use it to develop their space capacity back home.
Yes.
Put the money there. And I think if we can do that in the next 1-2 decades, I think Africa will be heading to the moon also.
You're so right on point, Dr. Taiwo. I'll close by saying this. After World War II, Japan was decimated. We both know, when we say decimated, we all know what decimation means. Yeah. There were 2 nukes, exploded on Japan in Nagasaki and Hiroshima. Their economy was at ground zero.
Yeah.
In fact, I can even tell you that at the end of World War II, China and Japan were more or less on the same level. But look at where we have today. China has launched several satellites into space. They are even a contender, to the Artemis, Accord with the International Lunar Research Station.
Yeah.
America didn't come to build it for them. Canada didn't come to build their ecosystem for them.
Yeah.
Japan is also a very mighty weight. Thanks to Japan, people like me and you, we are able to, get some of this knowledge that we have today.
Yeah.
Nobody did it for them. They did it by themselves.
Yeah.
We need African leaders to learn from this. No one is going to come and rescue you. We have to take the bull by the horn. We're very proud of you. We're very thankful to you. Joining this podcast, Dr. Taiwo Raphael Tejumola.
Yeah, thank you very much. Yeah, thank you very much for having me. And I mean, I'm always happy to, have this kind of discussion, honest discussion on how Africa will transition and how Africa will develop, and especially from the view or standpoint of capacity development. And thank you very much. And I wish Project D.A.W.N all the best in the near future.
Thank you so much, Professor. For our listeners and viewers, you can see we are not joking. We are calling the right people, the right muscle. We are putting everything we have to take Africa to space. Let's go. Thank you so much.
Thank you.